In the dead of night in August of 1975, the Bongqiao Dam in China failed. It unleashed a wall of water nearly 6 meters high and 12 kilometers wide. The wave moved at 50 kilometers per hour, erasing entire cities from the map and killing an estimated 171,000 people. Megadams are among the largest, the most expensive, and the most powerful structures humanity has ever created. But every single one of them, from the moment it is filled, is a loaded weapon, aimed directly at the people who live in its shadow. This is the story of why that weapon sometimes fires. Before we journey further, feel free to leave a comment with from what location you're watching this, and what time it is there. Now, settle in, as our exploration truly begins. The great and powerful rivers of the world have always been a profound and a dangerous paradox for human civilization. They are the great givers of life, the sources of the fresh water and the fertile silt that have nourished our societies for millennia. But they are also the great bringers of chaos, of unpredictable and ruinous floods, and of long withering droughts. The Megadam, therefore, was born from one of our most ancient and deeply held ambitions, the desire to bring order to this chaos. It is a tool of immense power, a machine that allows us to capture the immense energy of a river, to store its water for times of drought, and to protect the valleys below from its destructive rages. The great dams of the modern age are not just concrete and steel. They are profound and deeply optimistic symbols of our ability to control the natural world, to harness its power, and to create a safer and a more prosperous future. But this control, as we have seen, comes at a colossal and an often hidden price. The fundamental engineering challenge of any dam is to safely and permanently resist the almost unimaginable force that is exerted by the vast and heavy body of water that it holds in check. This is the world of hydrostatic pressure, a force that is as simple in its physics as it is colossal in its scale. The pressure that the water exerts on the upstream face of the dam increases with a relentless and an unforgiving linearity with every single meter of depth. This creates a vast and invisible triangular load that is constantly trying to push the dam over, and to slide it along its foundation. To combat this immense and ever-present force, engineers have, over the last century, perfected two primary and profoundly different philosophies of concrete dam design, two different ways of waging war against the immense weight of a captive lake. The first, the oldest, and the most brutally honest of these philosophies is that of the gravity dam. This is a structure that is designed to resist the immense horizontal push of the water with its own even more immense and even more colossal dead weight. A gravity dam is, in its very essence, a man-made mountain of concrete, a structure that is so profoundly and so unimaginably massive that the sheer force of its own gravitational inertia and the immense friction at its wide base are more than sufficient to resist the most powerful forces that the reservoir can exert against it. Its classic and powerful triangular shape is a direct and an honest expression of the forces it must fight. A design of pure. The second and more subtle of these great philosophies is that of the arch dam. This is a structure that is born not from the logic of the mountain, but from the quiet, the load-bearing, and the almost magical genius of the arch. An arch dam is a thin, an elegant, and a gracefully curved concrete wall, a structure that often seems to the naked eye to be far too delicate to hold back the immense power that it is containing. Its great and profound secret is that it does not attempt to resist the water's force with its own weight. Instead, its beautiful upstream curve is precisely calculated and designed to catch the great horizontal force of the water, and to intelligently and to efficiently redirect that force through the natural compressive strength of its arch shape away from the dam itself and into the solid, the strong, and the immovable rock of the canyon walls on either side. It is a structure that does not simply fight the river, it forces the very canyon that the river has carved to participate in its own containment. But whether the Great Dam is a colossal mountain of pure brute force mass, or whether it is an elegant and a gracefully curved and an intelligent shield, its long-term strength and its ultimate survival is completely and utterly dependent on a final, a crucial, and an almost entirely invisible element. The Great Dam is not a perfect and an isolated and a man-made object. It is a structure that must be perfectly and permanently, and intimately, bonded to the living, the ancient, the natural, and the often deeply and dangerously flawed rock of the earth itself. The true and the most profound and the most dangerous battle that any dam must fight is not against the visible force of the water that is pushing on its face, but against the silent, the hidden, and the insidious water that is constantly and perpetually trying to seep, to travel, and to push from deep beneath it, in a relentless and an unending effort to undermine and to destroy the giant's very foundation. The Great Dam, for all of its visible and overwhelming power, is engaged in a perpetual and a two-front war. It is not enough to simply resist the colossal, horizontal push of the water against its upstream face. An equally powerful and far more insidious battle must be fought against the very same water, as it tries to bypass the dam entirely, by traveling through the hidden and often flawed pathways of the ground beneath it. A dam's foundation is its Achilles heel. The living rock and the ancient soils of the earth are not the perfect, the solid, and the impermeable materials of our imagination. They are porous, they are fractured, and they are filled with a complex and an unseen network of cracks, of fissures, and of permeable layers. The immense pressure of the deep reservoir gives the water a powerful and a relentless incentive to find and to exploit these hidden pathways. This is the phenomenon of seepage. It is a constant and an often invisible flow of water that is perpetually trying to travel from the high-pressure world of the reservoir, through the ground beneath the dam, to the low-pressure world of the river valley downstream. A small and a controlled amount of seepage is an expected and a manageable part of any dam's life. But if this flow is allowed to become uncontrolled, it can lead to the most catastrophic of all foundation failures, a process known as piping. This is where the seeping water begins to flow with enough velocity that it can pick up and carry away fine particles of the soil from the foundation. This erosion creates a small underground channel, or a pipe. As more water flows through this new wider channel, it can carry away larger and larger particles, causing the pipe to grow with an almost exponential speed. This process can continue, completely unseen, until the foundation has been so hollowed out and so weakened that it can no longer support the immense weight of the dam above it, leading to a sudden, a total, and a catastrophic collapse. To prevent this, the first great act of a dam's construction is not to build up, but to dig down. An immense excavation is undertaken to remove all of the loose and unreliable surface materials, the topsoil, the sand, the gravel, and the weathered and fractured upper layers of the rock. This great excavation continues until the engineers have reached a deep layer of solid, of strong, and of competent bedrock that will serve as the true and the ultimate foundation for the great structure. But even this solid bedrock is not perfect. It is scarred with the ancient wounds of geological time, with cracks and with fissures and with faults. The next step, therefore, is a meticulous and a painstaking process of cleaning and of dentistry. The entire exposed surface of the bedrock foundation is cleaned with high-pressure water jets, and teams of workers will descend to clean out by hand every single crack and every single flaw, preparing the living rock for its permanent and intimate union with the new man-made concrete that will soon be placed upon it. With the foundation now prepared, the first and most important of the dam's great and unseen defensive systems is installed. This is the grout curtain. A line of deep and closely spaced holes is drilled deep into the bedrock in a line that runs across the entire canyon just upstream of where the heel of the dam will be. A thin and a cement-like grout mixture is then injected under immense pressure into these holes. This high-pressure grout is forced out into the surrounding rock, and it permeates into all of the finest and most microscopic of the cracks and the fissures. The grout then hardens, and it creates a deep, a permanent, and a completely impermeable underground wall, a vertical waterproof curtain that is sealed deep within the bedrock. This grout curtain is the dam's primary line of defense, a great and unseen barrier that is designed to block the most direct and the most dangerous pathways for the seeping water. But no grout curtain is ever perfectly and completely impermeable. A small amount of high-pressure water will always find a way to get past this first line of defense. And so, a second, and an equally brilliant line of defense is constructed just downstream of the first. This is the drainage curtain. Another line of holes is drilled into the foundation, but these holes are not filled with grout. They are left open, and they are all connected to a large and open and tunnel-like gallery that is built into the very base of the dam itself. The purpose of this drainage curtain is to act as a pressure relief system. Any of the high-pressure water that manages to find its way past the grout curtain will now encounter this line of open drainage holes. The water, following the path of least resistance, will flow harmlessly into these drains, and will then be channeled away by the great drainage gallery. This system acts as a permanent and a vigilant guardian, a system that is constantly collecting and safely removing the dangerous water that is trapped beneath the dam. This system is absolutely critical, because it is designed to fight the single most dangerous and most insidious of all the forces that are acting on a great gravity dam, the force of uplift. Uplift is the hydrostatic pressure of the seeping water as it acts on the bottom or the soul of the dam. It is a powerful and a vertical force that is constantly trying to lift the entire multi-million ton structure up off of its foundation. This force effectively reduces the dam's weight, and therefore it reduces its ability to resist the great horizontal push of the reservoir. An unexpected increase in the uplift pressure is one of the most common and the most terrifying causes of a catastrophic dam failure. The great drainage galleries that are built into the body of the dam are therefore not just simple passageways. They are the vital and the indispensable organs of the dam's long-term health and survival. They are the great internal arteries that collect and that manage the dam's seepage. They are the quiet and lonely and instrument-filled hallways from which the engineers will monitor the dam's performance for its entire century-long life. And they are the primary and the most important line of defense in the perpetual and the silent and the absolutely critical war against the enemy below. With this great and complex and redundant subterranean fortress of the dam's foundation now in place, with its deep and its impermeable grout curtain acting as its shield, and its pressure-relieving drainage system acting as its safety valve, the structure is now as secure as human ingenuity can make it, against the silent and the insidious and the ever-present enemy that is perpetually trying to attack it from below. The great stage is now, finally set for the main and the most visible and the most colossal of all the acts of construction. It is time to begin the raising of the great concrete mountain itself. But how exactly do you pour a single and a monolithic and a perfect concrete structure that can be wider than a dozen football fields and can contain more concrete than a small city? A single and continuous and uninterrupted pour would generate so much internal heat that it would tear the great dam apart from the inside out, long before it was ever completed. This leads us, inevitably, to the complex, the surprising, and the unexpectedly delicate science of mass concrete, and to the great and quiet art of taming the powerful and hidden fire that burns within the stone. With the great subterranean fortress of the foundation now meticulously prepared and secured against the insidious attacks from below, the stage is finally set for the most visible and most colossal of all the acts of construction, the raising of the dam itself. But this process is governed by a profound and a deeply dangerous paradox that lies at the very heart of its primary material. The great strength of concrete is born from a powerful and an exothermic chemical reaction. When cement and water are mixed, they begin a process known as hydration, a reaction that binds the sand and the gravel together into a single, monolithic and artificial rock. This reaction, however, releases an immense amount of energy in the form of heat. In a small concrete structure, this heat can dissipate harmlessly into the surrounding air, but in the colossal and almost geological scale of a mega dam, this heat has nowhere to go. The center of the immense concrete mass can reach incredibly high temperatures, while the outer surface, which is exposed to the air, cools down much more quickly. This vast temperature difference between the hot, expanding interior and the cool, contracting exterior creates immense and powerful internal stresses. If these stresses are not managed with an almost perfect degree of control, they will overwhelm the young concrete's fragile strength, and they will tear the great dam apart from the inside out, creating deep and catastrophic thermal cracks that would be a fatal and an unrepairable flaw in the finished structure. To build a single, monolithic mountain of concrete, therefore, the engineers must first accept a fundamental truth. They cannot build a single, monolithic mountain. The only way to safely construct a structure of this immense scale is to build it in a series of many, much smaller, and individually manageable pieces. The great dam is therefore constructed not as a single continuous wall, but as a vast and a three-dimensional and a vertical chessboard of independent and interlocking concrete blocks. These blocks or columns are poured one at a time in a carefully planned and alternating sequence, with narrow temporary gaps or contraction joints being left between them to allow each block to cool and to shrink independently. To create the precise and often complex shape of each of these great concrete cells, a system of massive and reusable steel formworks is used. These are, in essence, giant and incredibly strong and temporary molds which are craned into position and are then filled with the liquid concrete. The first and the most direct line of defense in this war against the heat is to ensure that the concrete is as cold as possible before it is ever placed. This is the science of pre-cooling. The raw and the natural ingredients of the concrete, the immense piles of sand and of gravel, known as the aggregate, are cooled by spraying them with chilled water, or by blowing cold air through them in their storage bins. In the most extreme of cases, such as during the construction of the great dams of the American West in the heat of the desert, an even more powerful technique was employed. A portion of the vast amount of water that was required for the concrete mixture was replaced with an equal weight of crushed or flaked ice. This allowed the engineers to dramatically lower the initial temperature of the concrete mix before the chemical fire of hydration had even begun. The second line of defense is to actively and powerfully remove the heat from the concrete after it has been poured. This is the science of post-cooling. Before a single drop of concrete is placed in a new block, a complex and a grid-like network of thin and seamless steel pipes is carefully laid out within the empty formwork. After the concrete has been poured and has completely encased this network of pipes, cold river water is then continuously, and for a period of many weeks or even months, circulated through these pipes. This system acts as a giant and an internal and an artificial circulatory system for the dam, a radiator that is designed to draw the immense heat of hydration out from the very heart of the concrete mass and to carry it safely and harmlessly away. Only when an individual concrete block has been allowed to fully cure and to fully cool and to shrink to its final stable dimensions can the final act of creation begin. The narrow and empty contraction joints that separate the hundreds of individual blocks are now finally ready to be filled. This final and crucial step is the grouting of the joints. A thin and a strong and a cement-based grout is injected under high pressure into these empty gaps. This grout fills the joints completely, and when it hardens, it stitches the hundreds of individual and pre-shrunk concrete blocks together into a single, a unified, and a monolithically powerful structure. It is only at this moment, after this final act of careful and of patient and of thermally controlled alchemy, that the great dam is finally ready to act as a single and a powerful entity, and to face the immense and the undivided pressure of the great lake that will soon begin to rise behind it. With the great and now fully cooled and fully stitched together fire that was once burning within the stone now finally tamed, and with the hundreds of individual and carefully managed concrete cells now perfectly and permanently joined together into a single, a unified and a monolithic mountain, the great dam finally stands at its full and its magnificent height. It is a profound testament to a deep and a quiet and a delicate mastery over the very chemistry of its own creation. But a great dam is not just a simple and an unthinking and an impenetrable wall. It is also a machine that must be able to safely, to intelligently, and to precisely control, to manage, and in times of great flood, to safely release the immense and the often chaotic and the untamed power of the great river that it has captured. How then do the engineers design the great, the powerful, and the gaping holes in the face of the dam, the great spillways and the deep and powerful outlets that are the essential safety valves that allow it to safely survive a 1 in 10,000 year flood? And how do they create the immense and the vortex forming and the water sucking intakes that feed the true and the ultimate and the industrial purpose of the modern megadam, the great and the powerful and the world-changing hydroelectric power plant? The great dam, now standing as a monolithic and unyielding mountain of stone, is a structure of almost perfect and impenetrable defense. But a dam that could not control or release the water it has captured would be a useless and a profoundly dangerous object. It must also be a machine, a complex and an intelligent system of gates and of valves that can manage the life of the river. Its most critical and most dramatic function in this regard is to act as a safety valve, a mechanism to protect itself and the entire valley downstream from the single greatest threat it will ever face, the rage of a truly catastrophic flood. A dam is not designed to withstand a flood by simply holding it all back. It is designed to allow the immense and unstoppable energy of a great flood, a once in 10,000 year event, to pass over it or through it in a safe and a highly controlled manner. To fail to do so would be to risk the ultimate catastrophe of overtopping, where the floodwaters rise up and over the non-spillway crest of the dam, an event that can rapidly and violently erode and destroy the entire structure. To prevent this, the engineers design and build the great spillways. The most common of these is the overflow, or service spillway. This is a section of the dam's crest that is deliberately designed and constructed at a slightly lower elevation than the rest of the dam, acting as a giant and carefully engineered overflow drain. The precise shape of this overflow crest is a masterpiece of the science of fluid dynamics. It is known as the OG crest, a smooth and mathematically precise S-shaped curve that is designed to perfectly match the natural parabolic trajectory of water as it flows over a sharp edge. This elegant shape ensures that the immense and fast-moving sheet of water remains smoothly attached to the face of the dam, preventing the formation of negative pressures that could cause vibration and damage to the structure. The flow of water over this great curved weir is controlled by a series of colossal steel gates. The most common of these is the tainter or radial gate. This is a massive and curved steel face, which is supported by a strong triangular steel frame that pivots on a great horizontal pin that is anchored into the piers of the dam. This design is incredibly strong and efficient, and it allows the dam's operators to open and to close these immense gates with a surprising speed and precision. The water that is released over a spillway is a force of almost unimaginable destructive power, a colossal and a high-velocity jet that can gouge a hole hundreds of feet deep in the bedrock of the river below, a process of erosion that could, over time, dangerously undermine the very toe of the dam itself. To combat this, a massive concrete structure is built at the foot of the spillway, the stilling basin. This basin is designed to do one thing: to kill the energy of the water. It is filled with a series of large and precisely shaped concrete blocks, known as baffle blocks and chute blocks. These great concrete teeth create a violent and a chaotic and a highly turbulent hydraulic jump, a contained explosion of energy that safely dissipates the water's immense power before it is allowed to continue its journey peacefully down the river. With the dam now safe from the threat of the great flood, it can now perform its true and its primary and its industrial purpose. This is the world of hydroelectric power. This process begins at another set of great gaping holes in the upstream face of the dam, the intakes. These intakes feed the dam's penstocks. These are a series of massive and often steel-lined pipes or tunnels, which carry the cold, the deep, and the incredibly high-pressure water from the bottom of the reservoir directly to the heart of the power plant. Here, in the great cathedral-like powerhouse that is built at the base of the dam, the immense potential energy of the water is converted into electricity. The high-pressure water from the penstock is channeled into a spiral casing that surrounds the heart of the machine, the turbine. The water, now moving at incredible speed, strikes the curved blades of the turbine's runner, causing it to spin with an immense and a powerful torque. The most common of these in our great dams is the Francis turbine, a marvel of fluid dynamics that is, in its essence, a highly advanced and an incredibly efficient water wheel. This raw, rotational, and mechanical energy is then converted into the final product. The spinning turbine is connected by a thick and a powerful steel shaft directly to the rotor of the generator. Here, a series of massive and powerful electromagnets are spun at a precise and a constant speed inside a great circular cage of tightly wound copper coils. This process of spinning a magnetic field inside a conductor is the simple and the elegant and the world-changing principle of electromagnetic induction, and it is what transforms the immense and the quiet and the heavy weight of the lake into the clean and the invisible and the almost weightless power of electricity. With its great and its powerful and its ever-vigilant safety valves now in place to protect it from the once-in-a-millennium rage of the river, and with its deep and its powerful and its constantly humming heart now quietly and efficiently converting the immense and the stored and the silent weight of the water into clean and into stable and into life-sustaining electricity. The great dam is now finally a complete and a functioning and a truly powerful machine. It is a profound and a monumental testament to our species' ability to impose our will and our order, and to extract immense and useful power from the otherwise chaotic and untamed forces of the natural world. But this great and this powerful act of control is not, and it can never be without a profound and an often a devastating and an almost always an irreversible cost. What happens then to the river itself? What is the unseen and the often uncounted and the deeply tragic price that is paid by the delicate and the ancient and the unimaginably complex and the life-giving ecosystem that the great and untamed river had once, for millions of years, so powerfully and so perfectly supported? This leads us, inevitably and soberly, to the other and the far darker and the far more troubling side of our long story, the great and the slow and the often tragic environmental ticking bomb that is set in motion the very moment that a great dam is built. The Great Dam stands as a monument to our ability to control and to conquer the natural world. It is a symbol of order imposed upon the chaos of the river. But this act of control, for all of its undeniable benefits to our civilization, sets in motion a cascade of profound and often irreversible and deeply damaging environmental consequences. The first and the most immediate of these is the Great Inundation. As the gates of the newly completed dam are closed and the river's flow is arrested for the very first time, the water begins to rise. It is a slow and a quiet and an inexorable flood, a man-made deluge that drowns meter by meter the entire vibrant and living world of the river valley upstream. Ancient forests, fertile farmlands, and entire complex ecosystems that have existed for millions of years are slowly and permanently submerged beneath the cold, the dark, and the still waters of the new reservoir. With them are often lost the homes, the towns, the sacred sites, and the ancestral lands of the people who once lived in the valley. A profound and a tragic human cost that is the first and the most visible price of the new dam. But the dam's most far-reaching and most insidious environmental impact begins with an act of profound and almost perfect thievery. A natural and untamed river is not just a channel of water. It is a great and a living conveyor belt. For millennia, it has carried a rich and a life-sustaining cargo of sediment, of silts, and of clays, from the mountains down to the sea. When this fast-moving river enters the calm, and the still and the deep waters of the new reservoir, its energy is suddenly dissipated. The river, in effect, dies. It drops its entire heavy load of precious and nutrient-rich sediment onto the floor of the lake. The dam acts as a colossal and an almost perfectly efficient silt trap. The consequences of this act downstream are profound and catastrophic. The water that is released from the dam is now clear, and it is starved of its natural sedimentary load. This hungry water has an excess of energy, and it unleashes this energy on the riverbed and the riverbanks below the dam, eroding them with a new and an unnatural ferocity, undermining the foundations of downstream bridges and infrastructure, and lowering the entire riverbed itself. The ultimate and the most tragic victim of this sediment starvation is the great and fertile river delta. The deltas of the world's great rivers, such as the Nile or the Mississippi, are some of the most fertile and the most ecologically important landscapes on our planet. They were built, grain by grain over a period of many millions of years, by the steady and the ceaseless deposition of the river's silt. With this vital supply line now cut off by the dam upstream, the delta is starved. It ceases to grow, and it begins to shrink, to compact and to sink into the sea, a process that is now being dangerously accelerated by the rising levels of our oceans. This relentless trapping of the river's sediment is not just an environmental disaster for the world downstream, it is a slow and an insidious and an inevitable form of suicide for the dam itself. The millions of tons of silt that are dropped by the river each year begin to accumulate at the bottom of the reservoir. Slowly but with an unforgiving and an inexorable certainty, the reservoir begins to fill up with mud. This process of sedimentation relentlessly and continuously reduces the dam's capacity to store water for the purposes of flood control, of irrigation, and of hydroelectric power generation. The dam is, in effect, a great and powerful giant that is slowly and silently being buried alive by the very river that it has tried to tame. Every mega dam on Earth has a finite and a predictable lifespan, a built-in and a geological ticking clock. The dam is also a profound and an unbreachable wall, a colossal concrete barrier that fragments the single, continuous, and living ecosystem of the river into two separate and completely disconnected worlds. This has a devastating and an often fatal impact on the migratory fish species, such as the salmon or the sturgeon, whose ancient and instinctual and essential life cycles depend on their ability to travel unimpeded from the ocean far upstream to their spawning grounds. The dam wall is a dead end, a catastrophic and an insurmountable obstacle that can and often does lead to the complete and the total collapse of entire and once thriving fish populations. The dam also fundamentally and permanently alters the very chemistry and the temperature of the water that it releases. The water that is discharged from the deep outlets of the dam comes from the cold, the dark, and the often oxygen-deprived bottom of the reservoir. This unnaturally cold and clear and oxygen-poor water can have a devastating impact on the downstream aquatic ecosystem, killing off the native fish, the insects, and the plant species that were perfectly and anciently adapted to the river's original and warmer and more turbid and more oxygen-rich natural state. This profound, this complex, and this often completely irreversible alteration of the river's very soul, from the slow and the silent and the inexorable death of its great delta to the complete and the total and the permanent fragmentation of its ancient and its finely tuned and its delicate life cycles, is the great and the often uncounted and the deeply tragic environmental price of the mega dam. The great structure that brings a new and a clean and an orderly and a powerful life to our world often brings a slow and a quiet and an almost unnoticed death to the great and the beautiful and the natural world that it has so completely and so powerfully conquered. But the great dangers of a mega dam are not just confined to the slow and the insidious and the often long-term and the ecological. A new and a far more direct and a far more terrifying and a far more immediate threat has emerged in the last few decades. A threat that was not even considered or dreamed of by the great and the confident engineers who built the first of the world's great dams. What happens when the very act of impounding a colossal and a multi-billion ton and a deep and a powerful lake behind a dam begins to alter the delicate and the ancient and the often fragile stability of the Earth's own living crust beneath it? This leads us inevitably to the deeply and the profoundly and the almost unbelievably unsettling and the incredibly dangerous phenomenon of reservoir-induced seismicity. For most of human history, we have understood our relationship with the Earth to be a one-way affair. We, in our smallness, are subject to the immense and the unpredictable and the often violent power of the planet. The ground upon which we build is the stage, and we are merely the actors. But the mega dam, in its colossal and almost geological scale, has changed this relationship. We have now learned through a series of startling and often tragic events that the construction of a mega dam is not a passive act. The very presence of the dam, and the immense artificial lake that it creates, is a force so powerful that it is capable of altering the delicate and the ancient and the often fragile stability of the Earth's own living crust. This is the deeply and the profoundly unsettling phenomenon of reservoir-induced seismicity. It is the shocking and the now scientifically established realization that our greatest and most powerful monuments of control can, in fact, under a specific and a dangerous set of circumstances, become the very triggers of geological chaos, and of powerful and of destructive earthquakes. This unsettling idea first began to emerge from a series of strange and anecdotal observations. In the 1930s, after the filling of the vast lake mead behind the newly constructed Hoover Dam, a region that had previously been almost completely seismically inactive, began to experience a series of hundreds of small and previously unrecorded earth tremors. For decades, these events were seen as little more than a scientific curiosity, but that all changed in the year 1967, at the site of the massive Koyna Dam, in a region of India that was, by all geological understanding, considered to be stable and ancient bedrock. Shortly after the reservoir was filled, a powerful and a devastating 6.3 magnitude earthquake erupted, with its epicenter located almost directly beneath the dam itself. The quake killed nearly 200 people and left a trail of destruction. For the first time, the scientific community was forced to confront the terrifying possibility that the dam itself, the very symbol of stability, had been the trigger for its own near-fatal disaster. There are two primary and powerful physical mechanisms by which a great reservoir can awaken the sleeping giants of the deep earth. The first and the most obvious is the colossal, and the almost unimaginable weight of the water itself. A large and a deep reservoir can contain many billions of tons of water, a new and an immense and a highly concentrated load that the Earth's crust was never designed to bear. This new and immense weight can be just enough to stress the underlying rock, and to trigger a sudden and a violent movement on a pre-existing but a previously stable and a previously unknown geological fault line. The second, and the far more subtle, and the more insidious of these mechanisms, is the effect of pore pressure. The immense weight of the deep reservoir forces the water, under incredible pressure, down into the microscopic cracks, and the pores and the fissures of the bedrock that lies deep beneath the lake. This high-pressure water then works its way down until it reaches an ancient and a deeply buried fault line. Here it acts as a powerful and an almost perfect lubricant. The water is forced between the two great and locked faces of the fault, and it pushes them apart, dramatically reducing the friction that was holding them, for so many centuries, in their silent and their stable embrace. This loss of friction can then allow a fault that was already under a great deal of natural tectonic stress to suddenly and catastrophically slip. It must be said that not every, or even most, large dams will cause an earthquake. This dangerous phenomenon requires a very specific and a very unlucky combination of factors: a very large and a very deep reservoir, which creates the necessary weight and pressure, and the pre-existence of a deep, a critically stressed, and often a completely unknown and invisible active fault in the bedrock, directly beneath the site. The great and the terrifying danger is that our knowledge of the deep geology of our planet is, and it will always be, incomplete. This is the element of geological roulette, that is a hidden and an often unaccounted for risk in the construction of every single new megadam. The problem was brought into sharp and tragic focus in the year 2008, after the catastrophic 7.9 magnitude Sichuan earthquake in China, a disaster that killed an estimated 80,000 people. In the years since, a number of seismologists and geologists have presented powerful and deeply unsettling evidence that suggests that the rapid filling of the massive Zipingpu Dam, whose reservoir is located just a few kilometers from the earthquake's epicenter, may have been the final and the critical and the catastrophic straw that broke the camel's back, a final and a man-made push that may have triggered one of the deadliest and most destructive earthquakes of our time. This profound and this deeply and this truly terrifying realization that our greatest and most powerful monuments of human control can, in fact, become the very triggers of an almost unimaginable and a deeply uncontrollable geological chaos, adds a new and a truly frightening and a deeply unsettling dimension to the concept of the great and the silent and the ever-present ticking bomb. It is a profound and a deeply humbling reminder that the dam is not just a passive structure, sitting on the surface of a dead and an inert world. It is an active and a powerful and a dynamic participant in a slow and a deep and an often completely invisible geological conversation. But the great threats to a dam are not always so grand or so dramatic or so seismic. A far more common, a more insidious, and a more mundane and a more patient enemy is constantly and silently and invisibly at work, an enemy that attacks not the deep and the living foundation, and not the ancient and the powerful earth, but the very and the seemingly eternal and the man-made concrete of the dam itself. What happens then, when the very materials from which we have so carefully and so confidently built our great and our powerful and our permanent mountain are themselves vulnerable to a slow and a silent and an internal and a completely irreversible and a hidden form of chemical self-destruction? We have explored the great and the powerful, and the dramatic threats that a mega dam must face. We have seen how it must fight against the colossal and visible force of the Great Lake and against the deep and the seismic and the often hidden forces of the earth itself. But there is another, and a far more patient, and a far more insidious enemy at work. This is an enemy that does not attack from the outside, but is born silently and chemically deep within the very heart of the dam's own man-made stone. It is a slow and an internal and a completely irreversible process of chemical self-destruction, a ticking bomb that is embedded at a microscopic level. This is the world of concrete degradation. We think of concrete as a substance of immense permanence, an artificial rock that once hardened will last for an eternity. But the truth is that concrete is a complex and a dynamic and a chemically active material, and under a specific and a dangerous and a surprisingly common set of circumstances, it can contain the seeds of its own slow motion and catastrophic decay. The great strength of concrete comes from its primary ingredients: cement, water, sand, and a much larger quantity of crushed stone or gravel, which is known as the aggregate. The aggregate is the inert and the strong and the bulky skeleton of the concrete. But sometimes this skeleton is not as inert as it seems. The problem begins when the aggregate that has been used to make the concrete, often sourced from a local and a convenient quarry, contains a certain and a chemically unstable and a reactive form of the mineral silica. This reactive silica, which is trapped within the concrete, then begins a slow and a secret and a destructive chemical affair with the highly alkaline cement paste that surrounds it. This is the beginning of a process that is known to engineers by a simple and a clinical name, the alkali-silica reaction, or ASR. The first product of this unwanted and illicit chemical reaction is the creation of a new and a strange and a glassy substance within the concrete, a silica gel. At first, this gel is a harmless and an invisible, and a microscopic byproduct, a secret that is locked away deep inside the stone. But this new and secretly formed silica gel has a powerful and a dangerous and an almost unquenchable property. It is highly hygroscopic. It has an immense and a powerful and an insatiable thirst for water, and it will begin to relentlessly and to powerfully draw in and to absorb any of the microscopic and ever-present moisture that exists within the pores of the surrounding concrete. And as this gel drinks, it swells. It expands with a slow but an immense and an almost completely unstoppable internal pressure. It is a process that is similar to the great and the slow and the powerful force of a growing tree root, a force that can, over time, crack and destroy the very rock around it. This is the true and the microscopic and the chemical ticking bomb that is now armed and is now growing deep within the dam. The first and the most visible external symptom of this deep and internal sickness is the appearance of a fine and a web-like and an interconnected network of cracks on the surface of the dam. This is a pattern that is known as map cracking, and it is the first faint and external signal that the great slow-motion explosion is happening from within, but these surface cracks are only a faint and a pale and a ghostly echo of the true and the immense damage that is happening deep inside. The relentless and the unstoppable swelling of the silica gel is creating a vast and a three-dimensional and an internal network of microscopic cracks, a network that is slowly and is silently and is completely and is irreversibly destroying the concrete's internal structure and its immense and its essential compressive strength. This unstoppable and internal expansion can, over a period of many decades, have a devastating and a grotesque effect on the entire colossal structure of the dam. Entire multi-million ton sections of the dam can begin to slowly but measurably grow, to bulge, and to move. This slow and powerful growth can cause the great and the precisely engineered contraction joints between the dam's concrete blocks to press against one another with an immense and a destructive force, causing the edges to crush and to spall and to fail. It can, over time, cause the subtle and the critical and the precision-engineered alignment of the dam's spillway gates or of its internal hydroelectric turbines to be dangerously and disastrously distorted. The most tragic and the most difficult aspect of this deep and this internal and this chemical cancer of the concrete is that for a dam that has already been built with a reactive aggregate, there is at present no known or effective cure. The chemical reaction, once it has begun, cannot be stopped. The only and the partial and the often a futile solution is to attempt to slow its progress. This is typically done by trying to keep the concrete of the dam as dry as is humanly, and as is technically possible. This can involve the expensive and the difficult, and the perpetual application of new and more advanced waterproof coatings, and of membranes to the upstream face of the dam, or by improving the efficiency of the grate and the internal drainage galleries. But to keep a structure whose entire and sole purpose is to hold back a colossal and a deep and a powerful lake of water, completely and perfectly dry, is an immense and an often a completely impossible and a truly Sisyphean task. In the most extreme and the most advanced and the most dangerous of cases, a far more drastic and a more brutal and a more desperate solution must be employed. This is a form of massive and of structural and of concrete surgery, a series of large and deep and strategically placed slots must be cut with immense and powerful and water-cooled and diamond-tipped saws deep into the body of the dam itself. These great and empty slots are designed to give the still swelling and the still dying concrete a safe and a controlled and an empty space to expand into. A last ditch and a desperate and an almost unbelievable effort to relieve the immense and the internal and the self-destructive pressures that are otherwise threatening to tear the entire great mountain apart from the inside out. This insidious, and this patient, and this currently incurable, and this internal cancer of the concrete, this slow, and this relentless, and this irreversible, and this almost invisible process of chemical self-destruction is one of the most profound, and the most difficult, and the most long-term of all the threats that a great mega dam can face. It is a quiet, and it is a patient, and it is a chemical ticking bomb, a profound and a deeply humbling reminder that even our strongest and our most permanent and our most powerful creations are, in the end, still subject to the slow and the subtle and the inexorable laws of chemical and of material decay. We have now explored the dam's great and its powerful and its external battles against the immense and the visible force of the water, and its deep and its secret, and its geological battles with the living earth beneath it, and its slow and its patient and its internal, and its chemical battles with the very materials of its own creation. But one final, and one immense, and one often completely overlooked, and one powerful component of the dam's great and complex and dynamic ecosystem still remains. What then of the great reservoir itself, the great and the placid and the man-made lake? Is not a simple and a static and a passive bathtub. It is a dynamic, and it is a powerful, and it is in its own right often a deeply dangerous and a sometimes a profoundly violent environment. This leads us now to the story of the hidden and the often the catastrophic, and the deeply powerful dangers that can and that do lurk, silently and often invisibly, within the still and the deep and the deceptively peaceful waters of the Great Lake. A mega dam is not an isolated structure. It is a single and a powerful component in a vast and a newly created geological and hydrological system. The great man-made lake that stretches for many kilometers behind it, the reservoir, is not a simple and a passive and a harmless bathtub of still water. It is a dynamic, and it is a powerful, and it is, in its own right, a deeply dangerous environment. An environment that can, under a specific and a terrifying set of circumstances, become the instrument of a disaster that is even more powerful and even more sudden than the failure of the dam itself. The creation of a deep reservoir is a profound and a violent alteration of the natural landscape. The steep and the ancient and the often fragile valley walls, which have for millions of years been shaped and stabilized by the gentle forces of the air and the rain, are now suddenly and permanently submerged. This immense and heavy body of water begins to slowly and to silently and to insidiously seep deep into the rock and the soil of the surrounding mountains, saturating them, lubricating their ancient internal planes of weakness, and dramatically increasing their weight. It is a process that can, over time, awaken a sleeping and a catastrophic giant, the most terrifying and the most tragic. And the most humbling example of this danger occurred on the night of October 9th, in the year 1963, at the Vejant Dam in the Italian Alps. The dam itself was at the time a source of immense national pride, a masterpiece of engineering that was the tallest and the most elegant thin-arched dam in the entire world. But it was a masterpiece that had been built in a profoundly and a tragically and a fatally flawed location. In the months and the years leading up to the disaster, a series of deeply ominous and almost universally ignored warning signs had begun to appear. The entire side of one of the mountains that formed the reservoir, Monte Toc, was slowly and measurably and unnervingly beginning to move. The ground had begun to creep. Great fissures had opened in the earth, and the local inhabitants had reported that the mountain itself was groaning and was shifting beneath their feet. The engineers, in a belated and a desperate attempt to manage the situation, had tried to lower the level of the water in the reservoir, but it was already far, far too late. In the darkness of that October night, the final and the catastrophic failure occurred. A colossal and a solid slab of the mountainside, a section of earth and of rock that was over 2 kilometers long and that contained more than 260 million cubic meters of material, detached, and it slid with a sudden and a terrifying violence at a speed of over 100 kilometers per hour into the deep and narrow reservoir below. This immense and fast-moving mass of earth acted as a colossal and a geological piston. It did not just create a splash, it instantly, and in a single, and in a brutal, and in a powerful act of physical displacement, pushed a vast and an almost unimaginable volume of the lake's water outwards and upwards. The result was a man-made and a geological, and a truly apocalyptic megatsunami, a single and an almost completely solid wall of water, which was estimated by later analysis to have been over 250 meters, or 820 feet high, rose up from the surface of the reservoir. This immense and almost unbelievable wave of water and of debris crested with a horrifying and a thunderous roar high over the top of the Vajont Dam, and it plunged with the force of an atomic bomb into the narrow and the peaceful Piave Valley that lay sleeping, far, far below. In a matter of 4 minutes, the town of Longarone and several other small villages were completely and utterly and entirely erased from the face of the earth, and nearly 2,000 people were killed. And in the silent and the stunned and the devastated aftermath of this great and terrible disaster, the most profound and the most chilling and the most humbling of all the ironies was revealed. The Vajont Dam itself, the slender and the brilliant and the elegant concrete arch, had survived. It had withstood the almost unimaginable and overtopping force of the great wave with only minor and superficial damage. It was, and it remains, a perfect and a pristine and a structurally brilliant testament to the genius of its engineers. The great and the tragic failure of Vajont was not a failure of concrete or of steel or of mathematics. It was a failure of geology, a failure of foresight, and a profound and a tragic and a fatal failure of human hubris. The engineers had successfully and had brilliantly and had perfectly built a magnificent and a flawless dam in what was, quite possibly, the single most dangerous and the most unstable and the most unsuitable location on the entire planet. The disaster was a powerful and a terrible and a deeply humbling lesson for the entire engineering world. A lesson that is written in the stone and in the sorrow of the silent valley. A lesson that the greatest danger to a dam can sometimes come not from any flaw in the structure itself, but from the immense and the powerful and the often deeply misunderstood, and the ancient and the sleeping and the ever-present power of the world that surrounds it. This terrible and this tragic and this almost unbelievable lesson of the great Vajont disaster is a profound and a deeply and a powerfully humbling reminder that a great dam is not an isolated and a man-made and an independent object, but is in fact a single and a powerful and a deeply interconnected component in a vast and a complex and an often a deeply fragile geological system. The greatest and the most powerful and the most catastrophic threat can sometimes come not from any predictable or any calculable or any understandable flaw in the great structure itself, but from the ancient and the often the hidden and the sometimes the unknowable and the powerful and the ever-present and the sleeping instability of the very world around it. We have now explored the immense and the complete and the terrifying catalog of the great and the powerful dangers that can and that do and that will always threaten these colossal and powerful structures, from the insidious and the patient and the secret seepage at their deep foundations to the slow and the internal and the chemical cancer of their concrete, to the deep and the powerful and the seismic forces of the living earth, and to the sudden and the violent and the catastrophic collapse of the very mountains that surround them. And yet, for all of this, many of these great and these powerful and these dangerous structures have stood, and they continue to stand and to function for a century or more. How then do we ensure their continued and their safe and their long-term survival? This leads us now into the quiet and the patient and the perpetual and the absolutely critical and the ever-vigilant world of modern dam safety, and to the deep and the complex and the ever-evolving science of monitoring the long-term and the hidden and the ever-changing health of a great and a powerful and a sleeping and an ever-present giant. The great mega dam, for all of its colossal and seemingly eternal strength, is not a simple and an inert and an unthinking object. It is a living and a breathing and a dynamic structure, one that is in a constant and a perpetual and a subtle state of flux as it responds to the immense and the ever-changing and the powerful forces that are acting upon it. The long-term survival of this great and powerful and potentially dangerous giant is therefore completely and utterly dependent on a philosophy of constant and of unwavering and of almost obsessive vigilance. This is the quiet and the patient and the perpetual world of modern dam safety, a world where the great silent structure is given a voice, a world where the engineer is engaged in a constant and a quiet and a deeply intimate conversation with the mountain of stone that they have created. The primary language of this conversation is spoken by the dam's vast and its complex and its almost entirely invisible nervous system. This is the network of thousands of highly sensitive and incredibly robust geotechnical and structural instruments that are embedded like delicate nerve endings deep within the concrete of the dam itself, and in the living rock of the foundation and the canyon walls that surround it. The first and the most critical of all the questions that these instruments must answer is about the health of the dam's great and unseen foundation. This is the job of the piezometer. These are specialized and highly sensitive pressure sensors that are installed in a series of deep boreholes that have been drilled into the bedrock beneath the dam. Their sole purpose is to constantly and to accurately measure the pressure of the groundwater, the great and the dangerous uplift force that is acting on the base of the dam. A sudden and an unexpected increase in the pressure that is recorded by a piezometer is one of the most serious and the most urgent of all the warning signs. It is a clear and an unambiguous signal that the dam's deep and internal drainage system may be blocked, and that the great and the silent and the dangerous enemy below is beginning to win its long and patient war. The second great question is one of movement. The great dam and the canyon in which it sits is constantly moving by microscopic and almost imperceptible amounts in response to the changing temperature and the shifting weight of the reservoir. To measure this movement, a host of other instruments are used. Extensometers, which are like long and sensitive and deeply anchored measuring rods, are installed across the great contraction joints of the dam and across any known geological faults in the canyon to measure with an incredible precision if these cracks and these joints are opening or closing. Inclinometers, which are like long and vertical and highly sensitive spirit levels, are lowered into deep tubes to detect any subtle and any gradual and any potentially dangerous tilting or bulging of the dam structure or of the great and the rocky canyon walls themselves. Deep within the very heart of the concrete, another, and an even more intimate set of sensors is at work. These are the strain gauges. These tiny and delicate and incredibly precise instruments are embedded directly into the concrete of the dam as it is being poured. They do not measure the movement of the whole structure, but the microscopic and the internal stretching and compressing of the concrete itself. They allow the engineers to, in effect, see the invisible rivers of stress and of load as they flow through the body of the dam, and to confirm that the great structure is behaving exactly as their complex and their powerful and their all-important computer models had predicted. This vast and internal and microscopic picture of the dam's health is then verified by a regular and an external and a large scale and an equally precise program of geodetic survey. A network of small and of permanent and of brass survey monuments is fixed to the crest of the dam and to the surrounding and seemingly stable landscape. Periodically, a team of surveyors will use incredibly precise and satellite-based GPS receivers and robotic and laser-guided total stations to measure the exact three-dimensional position of each of these monuments. By comparing the results of one survey to the next, they can create a perfect and a long-term and a millimeter-accurate historical record of how the entire great structure is moving and is deforming over the long and the slow and the patient and the powerful passage of time. This immense and this constant and this ever-growing deluge of data from these thousands of hidden and remote sensors is all fed, often in real time, through a network of armored and of fiber optic cables to a single and a quiet and an ever-vigilant central control room. This is the great dam's health center, the brain of its nervous system. Here, a small and a dedicated and a highly specialized team of dam safety engineers and of technicians, the true and the modern, and the quiet guardians of the great structure, will maintain their constant and their patient watch. Their job is to analyze this immense stream of data, to compare it to the historical records, and to look for any subtle and any almost invisible and any anomalous change in the dam's quiet and its normal conversation, a change that might be the first and the faintest and the earliest whisper of a new and a deep and a developing and a potentially dangerous problem. But for all of the power of this advanced and this remote and this incredible technology, the final and the most important component of this great and this perpetual system of vigilance is the simple and the ancient and the irreplaceable act of a direct and a physical and a human inspection. Regularly, a team of engineers will make the long and the slow and the often lonely journey through the vast and the cool and the dark and the echoing and the silent and the empty and the great internal galleries of the dam. They will walk and they will look and they will listen. They will look for the new and the telltale and the white and the chalky stains of efflorescence that signal a new and a hidden and a dangerous water leak. They will listen for any change in the sound of the water as it flows through the deep and the internal and the all-important drainage systems. And they will listen with a practiced and a sensitive ear to the deep and the resonant and the almost imperceptible and the low frequency and the powerful and the quiet and the living sounds of the great and the powerful and the ever-present and the sleeping and the always breathing giant. This constant and this multi-layered and this technologically advanced and this deeply human and this almost unending vigilance is the one and the true and the final and the essential key to the long-term and the safe and the continued survival of our greatest and our most powerful and our most potentially dangerous of all our dams. It is a perpetual and it is a quiet and it is a deeply profound conversation between the great engineer and the great and the powerful and the silent and the ever-present structure. But what happens then, when this great and this quiet and this perpetual conversation begins to reveal a problem? What happens when a great dam, after many, and after long, and after successful decades of faithful and of silent service, begins to show the inevitable and the dangerous and the unforgiving signs of its great and its advancing age, and is no longer considered to be safe by the strict and the ever-evolving and the ever-improving standards of our modern world? This leads us now to the immense, to the expensive, and to the incredibly complex, and to the often the very dangerous world of great dam rehabilitation, and in the most extreme, and the most final, and the most radical of all possible solutions, the deliberate, the controlled, and the almost unbelievable process of the removal of a great and a powerful and a once permanent mega dam. The great dam, for all of its colossal and its mountain-like permanence, is not an eternal structure. It is a machine that ages. It is subjected, every single moment of its long life, to the immense and the unceasing forces of the water, and to the slow and the insidious and the patient decay of its own materials. A dam that was considered to be a masterpiece of safe and of conservative engineering in the year 1940 may, by the far more advanced and the far more demanding and the far more knowledgeable standards of our modern world, now be considered to be dangerously and unacceptably obsolete. Our understanding of the great and the powerful forces of nature has evolved. Our models for predicting the true and the almost unimaginable size of a once-in-10,000-year flood have become far more sophisticated and far more terrifying. Our knowledge of the hidden and the seismic and the powerful dangers that lurk in the Earth's crust has grown profoundly, and our understanding of the slow and the patient and the chemical and the internal diseases that can afflict the very concrete of the dam itself has made us far more cautious and far more vigilant. And so we have now entered a new and a quiet and a deeply important age in the life of our great dams, the age of rehabilitation. For a great concrete gravity dam that is found to be no longer stable enough to resist the immense sliding or overturning forces of a newly calculated and much larger probable maximum flood, or a newly understood and much more powerful seismic threat, a remarkable and an almost unbelievably powerful solution has been developed. The dam must be pinned, it must be stapled, it must be bolted more securely to the living rock of the planet itself. This is the world of the post-tensioned anchor. The process is one of profound and of almost surgical, and of deep earth intervention. A series of long and of perfectly straight and of vertical or near vertical holes are drilled from the very crest of the dam, down through the entire massive body of the concrete structure, and then continuing for many dozens of meters more, deep into the solid and the competent bedrock that lies far, far beneath the dam's foundation. Into each of these immensely long and deep holes, a thick and an incredibly strong and a multi-stranded cable of high-strength steel, a tendon, is inserted. The very bottom of this tendon, the part that is deep within the bedrock, is then permanently fixed into place with a high-strength cement-based grout. Once this anchor point has cured, a colossal and a hollow and a hydraulic jack is placed over the top of the tendon, at the crest of the dam. This powerful machine then begins to pull, with a force of many hundreds, or even thousands of tons, on the great steel cable, stretching it and elongating it like a giant and a powerful and a deeply buried rubber band. When the required tension has been achieved, the top of the tendon is then locked into place, and the jack is removed. This great and now permanently stretched and now deeply powerful and now ever-present steel tendon, is now in a state of constant and of perpetual and of powerful tension, and it is a force that is now constantly and silently and powerfully pulling the entire multi-million-ton mass of the dam downwards, clamping it with an immense and an almost unbreakable force to its deep and its solid and its ancient rock foundation. But for some of our oldest and our smallest and our most obsolete dams, even these heroic and these expensive and these complex measures of rehabilitation are not enough. For a dam that has reached the end of its useful life, a dam whose reservoir has now almost completely filled with the river's relentless and unending sediment, and a dam whose ongoing and profound environmental damage now far outweighs any of the small and the dwindling benefits that it may still provide. A new and a final and a far more radical solution is now being considered and is now being enacted around the world. This is the age of dam removal. It is the process of deliberately and of carefully and of surgically unbuilding the great structures of our past and of freeing the great rivers that they have held captive for so long. This is not a simple or a quick or a violent act of explosive demolition. The unbuilding of a great dam is a slow and a painstaking and a multi-year process of deconstruction. The first and the most important step is the slow and the carefully controlled and the gradual draining of the great reservoir, a process that must be managed with an almost perfect precision. The single greatest challenge in any dam removal is the management of the immense and the often the toxic and the unconsolidated volume of sediment that has been trapped behind the dam for a century or more. To simply and violently remove the dam in a single act would be to release this entire multi-million-ton payload of mud in a single and a catastrophic and a destructive and a downstream flood. And so the removal of the dam itself is done in a slow and a phased and a carefully controlled manner. A small notch is first cut into the dam, allowing the river to begin to flow at its own natural pace. Through the structure once more, this newly freed and rejuvenated river will then begin the slow and the patient and the natural work of eroding and of transporting the immense volume of trapped sediment, piece by piece and grain by grain, and year by year, down to the sea. As the river slowly carves a new channel through its own long-lost sediment, the dam itself is then slowly and carefully and progressively and safely removed from the top down. The ecological rebirth of a river valley after a dam has been removed is often a stunning, a powerful, and a remarkably rapid, and a deeply moving, and a profoundly hopeful thing. The ancient and the long dormant seeds that have been buried in the mud of the reservoir will often spring back to life, and the great migratory fish whose timeless and whose essential and whose ancient and powerful life cycles have been blocked for a century will, with an almost immediate and an almost miraculous and an almost unbelievable and an instinctual certainty, return to the upper reaches of their long lost, and they're now finally, and they're once again free, and they're now once again wild, and they're now and they're forevermore, and they're beautiful, and they're ever flowing, and they're finally, and they're completely, and they're truly, and they're ever living river. This profound, and this hopeful, and this deeply symbolic act of the unbuilding of a great and an old and an obsolete dam is a powerful and a moving and a deeply honest statement. It is a clear and an almost an unambiguous recognition that our complex and our often fraught and our always evolving relationship with our great rivers and with the powerful and the beautiful and the ever-changing natural world is not a static and a permanent and an unthinking and an unchangeable thing. But while some of our oldest and our most obsolete of our great dams are now, with a great and a hopeful and a powerful and a new-found wisdom, being returned slowly and carefully and respectfully to the earth, we are at this very same moment embarking on a new and an even more ambitious and a far more colossal and a deeply and a profoundly and a far more controversial new age of the global mega dam construction. What then are the colossal and the continent altering and the deeply and the profoundly and the dangerously political projects that are now being planned and that are now being built all around our world? And what new and what even greater and what often the completely unforeseen and the powerful and the dangerous and the almost unimaginable new risks do these new and these even larger and these almost geological scale 21st century giants now present to our fragile and to our interconnected and to our ever changing and to our modern and to our ever more crowded world? Despite the immense catalog of dangers and the profound environmental costs that we have so far explored, the age of the megadam is not over. In fact, the dawn of the 21st century has ushered in a new and even more ambitious and a far more colossal global boom in the construction of these great and powerful structures, particularly in the rapidly developing nations of our world. The great drivers of this new boom are the same timeless and powerful imperatives that have always compelled us to tame our rivers. The insatiable and ever-growing demand for clean and for renewable hydroelectric electricity to power our modern economies, and the urgent and the ever more critical need to manage and to control our precious and vital freshwater resources in a world that is now facing the profound and the unpredictable challenges of a changing global climate. The undisputed and the almost incomprehensibly massive symbol of this new age of the Gigadam is the Three Gorges Dam, which spans the great and ancient Yangtze River in China. It is a structure of an almost geological scale, the single largest and most powerful hydroelectric power station on the entire planet. Its great concrete dam wall is over 2.3 kilometers long, and its vast and deep reservoir stretches for over 600 kilometers behind it. A colossal artificial lake that has forever and permanently and irreversibly altered the landscape and the life of the great river that it has conquered. The stated and the noble purposes of this great project were to generate a vast and a clean supply of electricity, to dramatically improve the river's navigability, and most importantly of all, to finally and forever tame the devastating and historically murderous floods of the great Yangtze River. But the construction of this modern wonder of the world came at a profound and a deeply and a staggeringly controversial human price. The creation of the immense Three Gorges Reservoir required the largest forced resettlement in all of human history, displacing more than 1.3 million people and submerging 13 entire cities, and thousands of years of irreplaceable archaeological and cultural history beneath the quiet and the still waters of the new lake. Beyond this immense human cost, a host of other, more subtle and long-term consequences have begun to emerge. The immense weight of the new reservoir has increased the risk of landslides along the valley's now saturated and unstable slopes, and the almost complete trapping of the river's sediment is having a profound and a devastating impact on the great and the vital and the ever-shrinking Shanghai Delta, many hundreds of kilometers downstream. The great and the powerful and the continent-altering gigadam of the 21st century has therefore become far more than just a simple and a domestic engineering project. It has now evolved into a powerful and a potent and a deeply and a profoundly and a dangerously political instrument of international and of geopolitical power. This is most true and most dangerous in the case of a transboundary river, a river that flows like the Nile or the Mekong or the Tigris, through the sovereign territory of multiple and of different and of often competing nations. In this delicate and dangerous landscape, the Great Dam becomes a weapon. The upstream country that builds the dam now has its hand on the tap, giving it the immense and almost absolute power to control the flow of the very lifeblood of the nations that lie downstream. The most potent and the most current and the most dangerous example of this new and this high-stakes global game of hydropolitics is now taking place on the Great Blue Nile River in the highlands of Ethiopia. Here, the almost completed Grand Ethiopian Renaissance Dam will be the largest and the most powerful hydroelectric project in all of Africa, a source of immense national pride and the key to Ethiopia's economic future. But for the great and the ancient and the almost completely desert nation of Egypt, which lies thousands of kilometers downstream, this very same dam is seen as a profound and a direct and an almost existential national threat. The civilization of Egypt has been for more than 5,000 years completely and utterly dependent on the steady and the reliable and the life-giving waters of the great river Nile. Their great and terrifying fear is that Ethiopia will now have the power to control and to diminish that vital flow, especially during the long and critical multi-year period that it will take to fill the dam's colossal new reservoir. These new and these continent-altering giga-dams and the profound and the often the very dangerous geopolitical tensions that they create represent the new and the complex face of the megadam in the 21st century. The ticking bomb is no longer just a matter of geology or of chemistry or of engineering. It is now also a matter of international diplomacy and of the fragile balance of power between nations. But as these new giants are being born, the old giants of the past continue their slow and their quiet and their patient and their inexorable process of decay. What happens when one of these older and these often forgotten and these often poorly maintained dams finally and inevitably fails? This leads us now to the anatomy of a disaster, and to the terrifying and the almost unbelievable and the split-second physics of a catastrophic dam break. A great mega-dam does not die silently. Its final moments are a process of catastrophic, of almost unbelievably rapid, and of terrifyingly cascading failure. It is a process that can transform a structure that has stood silent and immovable for a century into a roaring and a churning and an apocalyptic agent of almost unimaginable destruction in a matter of mere minutes. To understand this terrible transformation, we must now become the forensic engineers. We must slow down time itself, and we must examine with a clear and a cold and an unflinching eye the second-by-second anatomy of a great dam break. The final and the fatal sequence of events almost always begins with a quiet and an often and almost imperceptible and an easily missed and a final warning. In the last hours or even the last days before a great collapse, a series of subtle and of ominous and of deeply troubling new symptoms will often appear. New and unexplained and muddy leaks may begin to emerge at the downstream toe of the dam. A clear and a terrifying and a fatal sign that the process of internal erosion has begun. The immense and solid structure of the dam itself may begin to speak, emitting a series of quiet and of cracking and of groaning sounds. The sound of a great and a powerful and a dying giant's bones as they begin to break. The first and the critical and the unsurvivable wound is the initial breach. For a great earthen or rock-filled dam, this is often the moment that a long and a hidden and an internal erosion tunnel, a pipe finally and catastrophically, breaks through to the downstream face. For a great concrete dam, it may be the sudden and the explosive and the structural failure of a single and a weakened concrete monolith, a colossal and a multi-thousand-ton block that is pushed out from the face of the dam by the immense and the unceasing pressure of the water behind it. Once this first and small and initial breach has occurred, the full and the concentrated and the almost unimaginable power of the escaping water is unleashed. For an earthen dam, this high-velocity jet of water acts as a colossal and a high-pressure and a powerful saw, and it begins to violently and to exponentially widen the breach, cutting through the compacted earth and the rock fill with a terrifying and an almost unbelievable speed. The dam begins to, in effect, unzip itself from the bottom up. For a great concrete dam, the failure of a single block or a section of its foundation creates a catastrophic domino effect. The immense and the now unsupported hydrostatic loads are instantly transferred to the adjacent and the neighboring monoliths, which in a rapid and a thunderous and a catastrophic sequence also fail, and are toppled and are pushed downstream like children's toys. This is the moment that the great reservoir is finally and completely and totally and catastrophically unleashed. The sound is a thing that has been described by the few survivors of these events as being not a roar, but a deep and a physical and a ground-shaking and a terrifying vibration, the sound of a mountain of water, of 1 billion tons of liquid, being suddenly and violently and completely and totally set free. The great wave that is produced by a dam break is not a flood, in the conventional sense. It is a unique and a distinct and a terrifyingly powerful and a hydrological phenomenon. It is a massive and a high velocity, and a turbulent and a steep-fronted wall of water that moves down the valley not as a gentle and a rising and a slow-moving tide, but as a single and a coherent and an almost tsunami-like and a powerful and a destructive wave front. This great wave, which can be many dozens of meters high and can be moving at the speed of a freight train, has the power to destroy and to erase and to obliterate everything that lies in its path. It's immense and it's destructive, and its violent power comes not just from the water itself, but from the colossal and the almost unbelievable amount of debris that it picks up and that it grinds up and that it carries with it. It is a liquid and a grinding and a thunderous and an unstoppable bulldozer of water and of mud and of rock and of trees and of the shattered remains of the very bridges and of the very houses and of the very towns that it has just in the moments before so completely and so totally destroyed. In the quiet and the stunned and the silent aftermath of the great wave's passage, a new and a terrible and a completely alien landscape is revealed. The valley, which was once a living and a green and a vibrant world, is now a silent and a sterile and a post-apocalyptic scene of almost total and complete and utter devastation. The very soil and the very life of the valley floor has been completely and totally and utterly scoured away, leaving only the bare and the clean and the ancient and the dead and the silent bedrock below. It is into this silent and this devastated and this almost completely unrecognizable world that a new kind of team must now enter. These are the forensic engineers. Their job is to perform a painstaking and a meticulous and a deeply and a profoundly sad autopsy on the great and the dead and the now ruined giant. They must walk the wreckage, they must collect the evidence, they must study the broken pieces of the great dam, they must analyze the last and the faint and the final readings from its internal instruments, and they must slowly and they must patiently and they must carefully piece together the precise and the exact and the second by second and the fatal chain of events that led to the great and the final collapse. The forensic reconstruction of a great dam failure is a sobering and a deeply humbling and an absolutely essential process. It is a practice of learning from our most catastrophic mistakes, of reading the story that is written in the wreckage so that we can build safer and more intelligent structures in the future. We have now witnessed the full and the often the very terrible life cycle of the Great Dam, from its birth to its death. But our story has focused on the great dams of the past and of the present. What then of the future? As our climate changes, as our populations grow, and as our technology evolves, is the age of the megadam drawing to a close, or is it poised for a new and a different kind of rebirth? This leads us now to the final chapters of our journey. The future of our great rivers and the new philosophies that may one day come to replace the great and the powerful and the often the very dangerous mega dam, the long and the often the very troubled, and the difficult story of the mega dam has now in the early decades of the 21st century brought us to a profound and a critical and a necessary historical crossroads. For 100 years, the Great Dam was seen as an almost unambiguous symbol of progress, a heroic and a powerful act of taming, a chaotic and a dangerous natural world, but the hard-won and the often the very tragic and the deeply humbling lessons of the last century have forced us to reconsider this simple and optimistic narrative. We now understand with a clarity that was unavailable to the great dam builders of the past, the full and the complex, and the often the devastating and the irreversible long-term price that must be paid for this control. This new and sober understanding is now being met with the single greatest and most complex challenge of our time, the reality of a rapidly changing global climate. This presents a profound and a deeply difficult dilemma. On the one hand, the Great Megadam offers a vast and a powerful and a proven source of low-carbon, renewable hydroelectric energy. On the other hand, the new and the far more unpredictable and the far more violent weather patterns of our changing world, the patterns of deeper droughts and of more sudden and catastrophic floods, are now placing an immense and an unprecedented and a deeply dangerous new level of stress on these great and these aging structures. This new and complex reality is now forcing us to imagine a different kind of future for our rivers. A future that may not depend on a few colossal and centralized high-risk projects, but on a more intelligent, a more resilient, and a more decentralized network of solutions. One of the most promising of these is the philosophy of run-of-the-river hydropower. This is a technology that seeks to harness the energy of the river without destroying its life and its ecosystem. It works by diverting a portion of a river's flow into a powerhouse and then returning the water unharmed back into the river a short distance downstream. A method that uses the natural elevation drop of the river to generate power without the need for a vast and a destructive and a valley-drowning reservoir. Simultaneously, the meteoric rise of other and more flexible renewable technologies, particularly of solar and of wind power, is fundamentally changing the energy equation. The costs of these technologies have plummeted so dramatically in recent years that they are now often the cheapest and the fastest way to generate new electricity, offering a different and a less impactful path to a clean energy future. But this does not mean that our existing dams are obsolete. In fact, for many of them, a new and an even more vital and a more critical role is now emerging. In a world that is increasingly powered by the intermittent energy of the sun and the wind, our great hydroelectric dams are being repurposed to serve as the world's largest batteries. This is the genius of pumped storage hydropower. During the middle of the day, when the sun is shining and the solar panels are producing a vast surplus of cheap or even free electricity, the great turbines of the dam can be reversed. They can be used as immense pumps to move water from a lower reservoir or from the river below the dam back up into the main upper reservoir, effectively converting the surplus electrical energy into stored potential energy. Then, in the evening, when the sun has set and the demand for electricity peaks, this stored water can be released back down through the turbines, generating a massive and an almost instantaneous supply of clean electricity. This ability to store and to release vast amounts of energy on demand makes these old dams the great and the silent and the indispensable stabilizing force for a new and a modern and a renewable and a clean and a powerful and a stable and a reliable and a future-proof and a green and a modern and a powerful and a stable and a reliable and a future-proof and a green energy grid. The hard-won lessons of the past are now informing a far more cautious and a far more holistic and a far more intelligent approach to the management of our great rivers. The new focus is increasingly on a portfolio of solutions, on a balance between the hard and the gray, infrastructure of our concrete dams and the softer and the greener, and the more natural infrastructure of a healthy and a resilient river system. This is the world of nature-based solutions. It is the growing and the powerful and the hopeful and the inspiring movement of river restoration, of the deliberate removal of old and obsolete dams, of the reconnection of our rivers to their natural floodplains, and of the use of healthy and of vibrant and of living wetlands and of forests to manage the flow of water, to prevent the great floods, and to ensure the long-term health and the long-term stability and the long-term survival of our most precious and our most vital and our most essential of all our natural resources. This new and this more complex and this more cautious vision for the future of our rivers, a vision that balances our immense need for power with a newfound and a hard-won respect for the intricate and the vital power of the natural world, represents the beginning of a new chapter in our long and our often troubled relationship with our planet, the age of the colossal and the unquestioned, and the almost heroic mega dam may be drawing to a close, to be replaced by a new and a more intelligent and a more balanced and a more sustainable portfolio of solutions. As we now, finally, reach the end of our long and our detailed and our often cautionary journey, we are left with one final and one essential task. We must pull back from the specifics of the engineering, of the disasters, and of the future to reflect on the enduring and the timeless and the deeply human meaning of these great and powerful structures. What is the ultimate lesson that these silent, concrete mountains have to teach us about the nature of power, of progress, and of our own often fragile place within the natural world? As our long and cautionary journey comes to its end, we are left to reflect on the enduring meaning of these silent, concrete mountains. They are a profound and deeply troubling paradox. On one hand, they stand as magnificent monuments to the very best of our ingenuity, a testament to our species' ability to dream on a geological scale, to impose a human order on a chaotic world, and to harness the elemental forces of nature to create a better and brighter future. They are symbols of a heroic 20th century confidence, a belief that any problem could be solved with sufficient ambition and concrete, yet at the very same time, these structures are somber and powerful monuments to our own hubris. They represent a frequent and tragic failure to understand the complex and delicate interconnectedness of the natural world. Each risk that we have explored, from the insidious seepage that undermines a foundation, to the slow chemical cancer that decays the stone from within, to the catastrophic fury of a reservoir-triggered earthquake, is a lesson born from our inability to foresee the full and true consequences of our own immense power. The mega dam is therefore a symbol of both our greatest strengths and our most profound and dangerous weaknesses. In the end, the ultimate lesson of the mega dam is not about the dam at all. It is, and it always was, about the river. The great silent and patient concrete structures that we have built are, for all their colossal power, merely temporary and fleeting interruptions in the life of a force that is far more ancient, far more powerful, and far more permanent than any object that we can ever hope to create. These great dams are now more than just power plants or flood defenses. They are vast and somber libraries of stone. They are the great, hard-won encyclopedias of our own long and difficult education, and the quiet and the eternal and the ever-flowing voice of the river that they have captured is the teacher. It is a voice that speaks to us across the great and silent centuries of the profound and essential wisdom of humility, of the complex and beautiful power of a world that can be collaborated with but can never be truly and finally conquered.